Welcome to part 2 of our quadratic formula lesson. In this video, we are going to solve quadratic equations with imaginary solutions. Let's begin with a quick review of square roots, including those with negative numbers. In this first one, we have the square root of 49. It equals 7, because 7 times 7 equals 49. On the second one, we have a negative square root. And since a negative times a negative equals a positive, when we're using the real number system, there is no square root of negative 64. However, if we expand our universe to include the imaginary numbers, then we can proceed. So let's break down the square root of negative 64 into the square root of negative 1 times the square root of 64. The square root of negative 1 equals the imaginary number I. And then the square root of 64 equals 8. So the square root of negative 64 equals 8i. Now I is not a variable, it's actually a number. So just keep in mind that I equals the square root of negative 1. All right, let's simplify some square roots. When we simplify with square roots, we're trying to think of a number that is a factor of the number underneath the square root sign. And we want that number to be a perfect square root. So for instance, with the square root of 75, we can break that down into the square root of 25 times the square root of 3. And this is helpful because the square root of 25 is equal to a plain old 5. So the square root of 75 equals 5 times the square root of 3. We can do the same thing with negative square roots. We'll break this down into the square root of negative 1 times the square root of 9 times the square root of 3. Now the square root of 9 equals a plain old 3. And the square root of negative 1 equals the imaginary number I. So this equals I times 3. And the square root of 3 just tags along. Let's rewrite this so it looks how we expect it to look. We'll write 3i times the square root of 3. Here we have a fraction with a sum of an integer and a square root in the numerator. Well, let's try to break down the square root of 300. So that will be the square root of negative 1. Now, 100 is a perfect square root, so we will break that down into the square root of 100 times the square root of 3. Still, all of it is over 2. The square root of negative 1 equals I. The square root of 100 equals 10. So let's go ahead and rewrite that. Now we notice we can divide each of our 3 terms by 2. So we're dividing the numerator by 2, and we're dividing the denominator by 2. 2 divided by 2 equals 1. 10 divided by 2 equals 5. 2 divided by 2 equals 1. When a fraction has a 1 in the denominator, that denominator is inconsequential, so we can just get rid of it. And we're left with 1 plus 5i times the square root of 3. Now the quadratic formula helps us solve quadratic equations. So when we have an equation written in standard form like this, equal to 0, the coefficient of x squared we call a, the coefficient of x is b, and the constant term is c. And we can use those coefficients and constants to solve for x. In fact, x equals the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all of that over 2a. The nice thing about the quadratic formula is that it always works. Some of our other methods only work sometimes. So here we have an equation x squared minus x plus 5 equals 0. We're trying to solve for x. Now it's always a good idea to think if we can factor a quadratic expression before using the quadratic formula. But in this case, there are not two numbers that multiply to make 5 that add up to -1. So we will move to our option 2, which is using the quadratic formula. All right, x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. Well, here we have an a of 1. We understand there's a 1 in front of the x squared. b equals -1, and c equals 5. All right, so here we go. We're solving for x. X equals the opposite of b. Well, b is -1, so the opposite of b is +1. So the opposite of b plus or minus the square root of b squared minus 4 times a times c. All of that over 2a. Let's keep simplifying. We'll start underneath the square root sign. So -1 squared is -1 times -1, which is +1. Let's see, we have a negative times a positive times a positive, so that will stay negative. So I'm just going to write my subtraction sign. And we have, let's see, -4 times 1 is -4, times 5 is -20. So we have 1 minus 20, and all of that over 2. We'll subtract underneath the square root sign to get -19. If we were only using the real number system, we would say no solution. But since we now can use imaginary numbers, we'll go ahead and continue. So the square root of -19 is the square root of -1 times the square root of +19. So that'll be I times the square root of +19. All that over 2. Now 19 is, we cannot simplify that. It's not a perfect square root either. And there is no simplifying to do with the fractions. So we'll go ahead and stop there. Now always keep in mind that there are actually two solutions here. We have x equals 1 plus I times the square root of 19 over 2. And x also equals 1 minus I times the square root of 19 over 2. Just to save time, we like to write it with that plus or minus. Quick reminder here, in the quadratic formula, you need to get your quadratic equation equal to 0 before you begin. So let's subtract 5 from both sides. So rather than trying to factor this, let's just go ahead and jump straight to the quadratic formula on this one. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. So in this case, a equals 4, b equals 2, and c equals 1. So if x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c. All that over 2 times a. Let's continue simplifying underneath the square root sign. 2 squared equals 4. Let's see, this is going to stay negative because there's only one negative number here, so I'm just going to put my negative sign there. Let's see, we have -4 times 4 is -16 times 1 is -16. So 4 minus 16, all of that over 8. Let's continue by subtracting. 4 minus 16, that's -12. All of that over 8. All right, we're a little disappointed here because we can simplify the square root of 12. So let's continue with that. All right, we have -1 times of a couple of square roots here. Now we could do 6 times 2, that would be true, but it would not help us because neither 6 nor 2 are perfect square roots. But if we use 4 times 3 to get this 12, this helps us simplify because the square root of 4 equals 2. We still have that 8 in the denominator. All right, simplifying these square roots here, we have, the square root of 4 is 2, and the square root of negative 1 is I, so that'll be 2I times the square root of 3. And all of that over 8. We can divide each of our 3 terms here by 2, so let's go ahead and do that so that we fully simplify it. So we're dividing the numerator by 2, and we're dividing the denominator by 2. Negative 2 divided by 2 is negative 1. And then 2 divided by 2 is 1, so that leaves us with I times the square root of 3. And 8 divided by 2 equals 4. So we were able to simplify. We still have a denominator, but now we are all set. I hope these examples have been helpful about using the quadratic formula to solve quadratic equations that have imaginary solutions. This is Mr. Ela, signing off.